How you doing?
Hey, today we'll be doing a demonstration on physical and chemical changes, so you can actually just have a seat right there. So, first of all, we're going to talk about physical changes. So this is a piece of paper that I'd like you to record a couple of things down on. So first of all, we're talking about physical change, and we're going to start out with this ice cube. Now as you can see, I can take it out right here in my hand. I'm just going to keep it in this container. So I just want you to write down what this ice cube looks like.
Okay.
So take like 30 seconds, just quickly write down.
Describe it or just what it looks like?
Yeah, just describe it and what it looks like. Here, and I'll take it out and you can see. Okay, awesome, thank you. So this ice cube, as I am even taking it out, it's starting to melt into water. Now, I'm going to put this ice cube on this back stove burner, and we're going to observe what happens to it. So, take the ice cube, we'll just put it in this pot, and we're going to leave that going for just a minute. We'll come back to that in just a minute. So, in talking about physical change can change. When we talk about physical change, we're talking about a change in the appearance or in the state of an object. So if it's solid, liquid, or gas, changing anywhere between those states will still make ice made of the same molecules. Like it'll still be H2O, which we call water. But when water is frozen, we call it ice. When it's not frozen, we call it water, right?
Right.
Okay, awesome.
And then steam.
Yep, and then steam. So, as you can see, it's already starting to melt a little bit. We're going to keep that on for just another minute or so and see what happens with that. Let's move on to example 2 while we're waiting. Okay, so I have this. I want you to go ahead and write down, describe what this is.
It's an egg.
Mm-hmm. Oh, I'm sorry. We're going to come back to this example in just a minute. We'll set that down.
Okay.
Okay. We have here just a piece of paper, right?
Yeah.
I want you to go ahead and describe this piece of paper. Okay. What is this now?
2 pieces of paper.
Okay, great. So it's still a piece of paper, right?
Yeah.
So just because I change the physical appearance of something, it's still paper. That is another characteristic of physical change. You can change this appearance or the look of an object, but we're not changing that this is in fact paper. So I'd like you to take a minute and just rip those pieces of paper up into little pieces. And I'd like you to put it in this pan right here. Alrighty, so I have a question for you. Why do you think this is still called paper, even though it's in smaller pieces?
Because it's still paper. I don't know. Because you're just changing the size of the paper.
Okay, yeah, exactly. So this paper, no matter how small you rip it or no matter how big it is, it will still just be paper.
So sometimes they call it like confetti.
Mm-hmm. And confetti is usually made sometimes of different materials. So we have different names, just like we have different names for water when it's solid, liquid, or gas. We also sometimes have different names for paper, even though it's the same thing.
Into ashes?
You'll find out. Okay, we're going to come back to our ice cube now. Okay, now I want you to describe what you see.
I see water.
Exactly. Okay, can you feel any more ice?
A little bit. It's cold water.
Okay, cold water. But as you can see, it's melted. I don't know if you can see that all the way. But it has melted into water. Okay, so this is still water, right?
Uh-huh.
And if we put it back into this
It used to be
container.
ice.
Yeah, it used to be ice, now it's water. But if we put this back into this container and stick it back into the freezer, what's going to happen to this water?
Go back to ice.
Exactly. So that's another aspect of physical change. We can change from state to state, and it's reversible. So for example, I could put this in the freezer, turn it back into ice. We could do this experiment again, put it back, it would turn back into water. If we kept letting it go until it boiled, then it would become steam. And then if we had a little
Catcher.
a catcher, we could take that steam, and then if it got cold enough, it'd turn back into water, which would turn back into ice if we then put it in the freezer. So that's another aspect of physical change, that it's reversible. Okay? So, I want to hear, just in your words, what is a physical change?
Physical change is when something is reversible. Like you can, like with water, it can go from its ice state to water state to steam, and then from steam back to water, back to ice.
Mm-hmm. Awesome. Does it change the makeup of the object? Like the composition?
No, it's still the same. It's still the same.
Okay, awesome. So now we're going to talk about something a little bit different, which this is a chemical change. So now we're going to come to the egg, which you started to write down what you can see so far, right? Okay, so what would happen, or what is, like, do most people eat an egg like this?
Not most people.
Do you eat eggs like this?
I have.
You've just drinking it, eaten it?
Yeah.
Oh, that sounds gross. But most people wouldn't eat an egg like this. Why do you think most people don't eat eggs that are raw?
Well, because it could give you disease. I don't know.
Yeah.
Because they don't like the texture.
Yeah, that's true. So a lot of people don't eat eggs because there's some diseases that are found, usually with eggs. A lot of times it's salmonella. Yeah, that's right. So, a lot of people don't eat this egg because of a disease that could come because it's not cooked. However, we're going to now take a minute to cook this egg. So we'll crack this right here. Alrighty, still looks the same, right? We just set it in a pan. See if you can get that. Okay, now we're going to stick it on this burner right here. We're going to turn that on high for just a minute, okay? We're going to come back in just a second and look and see what that looks like. Okay, perfect. Okay, we're going to come back to that. So now we're going to go back to the paper. We've got these pieces of paper, as you can see, small little pieces. And instead of now just changing the physical appearance, we're actually going to change the chemical makeup of this. We're going to do that by burning it.
Can I burn it?
Yeah, go ahead and light it and just stick and make sure it gets into that pan.
I got it.
Awesome. So you can stick a couple of matches in there. So every year for Christmas, my family actually writes a letter to Santa Claus. And we take our paper that we've written down what we would like, and we light it on fire.
What?
Mm-hmm.
Why?
Because then it turns the paper into, you mentioned this earlier, do you know what it's called when paper's burned? It turns into ash. So ash is no longer paper. It's not just a different state because we actually can't change ash back into the piece of paper.
So why are you burning your letters to Santa?
So we burn our letter to Santa Claus because he is magical and he can take the ash, and he is magical so he can overdo that chemical change and cause it so that he takes that ash and puts it back into paper. But we can't do that because we actually caused a chemical change. So if you can see, you can see in there that the paper starts turning brown and it's going to turn into ashes. If we burned it long enough, that'd turn into ashes.
So
Yeah, go ahead. Do you have a question?
we're not gonna do that for our kids.
That's fine.
I'm just kidding.
Okay, so next if we come
They
back,
burn their letters.
to this egg, you can see that it's starting to cook. or it's starting to, cook. Why is it cooking? That might seem like a simple question, but what's causing this egg to cook? Yeah, so the heat. So this heat source is actually causing the egg to turn and have a different chemical makeup, and that's why we can eat eggs that are cooked instead of eggs that are raw. So once we cook this egg, we are not really likely to get a disease from it because it's cooked. So a chemical change is when we're either, it doesn't have to only do with heat, but heat is one way that these two subjects have changed into different materials, into ash and into a cooked egg.
Do you chemically change through cold?
No, that's a great question. I don't know. I would think that a lot of things maybe don't necessarily change because it might change their state, but that's a good question. You should research that and let me know.
Yeah.
Okay. So as you can see, that's one more reason why we cook all of our food, so that we make it safe. So, if you had to describe to me what the difference between a chemical and physical change is, what would you say it is?
Physical change you can get back, and chemical change you can't get it back.
Mm-hmm. And what happens to like a substance that has had a physical change versus a chemical change? Is it still the same substance after physical and or a chemical change?
So?
Or is it still the same thing? So if we take a piece of paper and a physical change occurs, is it still a piece of paper?
Yes.
Awesome. And if we change and do a chemical change on that piece of paper, is it still a piece of paper?
No, now it's ash.
Yeah. We change the chemical makeup of it. So, do you have any questions?
Yeah, so how do you know if you're doing a chemical change if it just turns into like, so water turned into ice, which is a change. Paper turned into ash, water turned into ice, but one of them is different than the other.
True.
Why?
So the actual makeup of the material changes. So like water, we just happen to have given it different names for each of the stages. So when it's above a certain temperature, then we call it ice. Or sorry, when it's like below 32 degrees. And it can go back and forth in between. So we could do this experiment with water, stick this back in the freezer. It could change, we could pull it out, melt it, steam it, melt it, or go back, condense it and get it back to water, freeze it, get it back to ice. But like this egg, because this egg, now it's still a little bit raw. I would not want to eat it like this. But because we've already started to cook it, we can't get the raw egg back.
So, basically my question is if, so paper being ripped up is a physical change?
Yes.
But paper being burned is a chemical change?
Yes.
Okay, I get it.
Okay, alrighty, thanks, and that's physical and chemical changes.